Good morning or good afternoon for everybody, because we do this video to working at our presentation. So I don't know what is exactly time, local time in Las Vegas right now. So I see either good morning or good afternoon for everybody. So it's my honor to have this good opportunity to share some research and study we did recently in my college and my co-worker. The topic I try to present today is estimate and predict fire index using adaptive neural-fuzzy inference system and artificial neural network algorithm. My name is Ying Bai, and I'm a professor teaching in the Department of Computer Science Engineering at Johnson C. Smith University, located in Charlotte, North Carolina. My co-worker, Dali Wang, he's also professor teaching at Department of Physics, Computer Science in the Christopher Newport University in Virginia. First one, let me give you a quick introduction. What is the purpose for our research? As everybody know, in recent years, we have terrible, maybe tremendous damage introduced by the wildfire or forest fire. That is worldwide, not nationwide, such as in the Brazil, California. Those fires not only make big, huge, tremendous damage for economic, but also for the human being life. Okay, so that is critical to figure out or to find a way to can be used to estimate or predict how dangerous degree and this wildfire can be occurred. So in this study, we use adaptive neural-fuzzy inference system simplified ANFIS, artificial neural network, simplified ANN. We use the two algorithms, we use the two ways together. We develop two systems. That two systems used to predict, estimate the possibility of generation of forest fire by using fire weather index. Basically, this method, two methods, can be used by some decision maker or policy maker. They can, based on our research study result, they issue some command and predict national or worldwide personal property from being damaged or reduce the degree of those damage. As I mentioned today, across the entire world, the frequency and the size of forest wildfire are rapidly increasing. I think maybe one of the most important reasons is due to the global warming. Yes, as the temperature go up and up, the possibility of the wildfire generation become higher and higher. Okay, this destructive forest fire or damage result in billions of dollars per year, not only per decade, no, each year. Okay, so that is the reason why it is critical to correctly estimate and predict the possibility of occurring of forest fires. Recently, we have so many research study report about this or wildfire, how to predict, how to predict, how to estimate. The key issue is that most recent study, they only concentrate on relying on mathematical prediction and physical-based model. So by using those models, very difficult and very time-consuming to run those models. So in this study, we develop a system with ANFIS and ANN to correctly estimate a fire weather index value in real time based on the given input parameter. Those input parameters can be found and have been defined by Canadian fire weather index system. So this paper recognized by following section. Definition structure of Canadian FWI, first given section 2. Introduction to adaptive neural fuzzy inference system and neural network given in section 3 and 4. Section 5 provide conclusion, acknowledgement, section 6. So first one, let me take a quick look because this very complicated system. We don't have time to give a full description, but we try to give a quick introduction about the Canadian fire weather index. Exactly, Canadian government defined a system we call the Canadian Forest Fire Danger Rating System, or simply a CFFDRS. The Canadian Forest Fire Weather Index, FWI, is a subsystem of CFFDRS. Basically, this FWI system composes 6 components with the 2 layers. Okay, so those systems can be used to estimate or calculate the potential degree of wildfire will be occurred. So let me take a look a little more detail about this FWI system. So I mentioned we have 2 layers. Top layer is a fuel moisture code layer, and bottom layer is a fire behavior index layer. We have a top layer 3 components: fine fuel moisture code, depth moisture code, drought moisture code, or simply FFMC, DMC, DC. Those is quantitative description. On the bottom, we have intermediate 2 intermediate level: initial spread index, ISI, and build-up index, BUI. Combine these 2 intermediate items, finally we get fire weather index. Fire weather index is a qualitative description to indicate how many dangerous degree about wildfire can be happen. And the bottom is qualitative description. So let me get to a little more detail. So on top 3 there, I mentioned we have FFMC, DMC. Top 3 layer only provide quantitative description for fuel moisture and the draw degree on the studied area. Bottom, we have a 2 intermediate level, ISI, BUI, and combine that 2 layer, we get last component weather index. So the 3 components in the bottom layer that provide qualitative description with a fire behavior index to indicate the possibility or dangerous degree of the wildfire to be occurred. This gives for a more detail about what is the definition about FFMC, DC, ISI, BUI, FWI. This is only a definition, okay? Yeah, FFMC is a numerical indicator, moisture contents of liter and other cured fine fuel. DC is numeric reading. ISI is combined FMC and wind speed together indicate expected rate of fire spread. BUI is weighted combination, DMC and DC. Finally, we get FWI. In summary, the FWI value is a key parameter or indicator. It could be used to indicate how dangerous or what is the degree of forest wildfire would be occurred. We have quite of the a few researcher and study report for the by using the FWI value, analyze the forest wildfire condition and build related model. However, few studies, not too many, few studies, they concentrate on the driving FWI value by using ANFIS AN algorithm. Okay, this is our research in this study. We don't use a mathematical method. Basically, let me concentrate to our method. Firstly, ANFIS. The so-called adaptive neural fuzzy inferior system exactly is a combination. Two soft computing method, neural network fuzzy inferior system. That first introduced by the Zhang Shan, Rock Zhang in 1992. Exactly the fuzzy inferior system uses a pseudo fuzzy inferior system. We have two kinds of structure similar to a multi-layer feed-forward neural network. Okay, the difference is that the link between nodes in ANFIS define the signal's flow direction and no associated weight factor. Okay, so let me take a look about the so-called pseudo-fuzzy model. Next slide. So in this study, we only use the 3 inputs. Regularly based on the Canadian FWS, they use the 4 inputs. The temperature, relative humidity, and wind speed, also plus rainfall. But later on, I will show you guys, we use some data set. We find the rainfall play a not significant role, not too many effects. So we just concentrate by using 3 inputs. So temperature, relative humidity, wind speed. So the first one, in the first, we use the membership function. We divide temperature into 3 levels, high, medium, low. Relative humidity is similar, high, medium, low. For the wind speed, we develop also 3 levels, faster, average, slow. So after using membership function, we do the fuzzification to the 3 input variable. And then following, we're using artificial neural network. We use a different node, okay, with a different weight parameter, W11, W12. Next page, I gave you a definition about W11, W. This is a weight factor. Finally, we use combine everything together. We get FWI. We have 5 layers. Okay. So we totally use 9 rules for fuzzy inferior system. If that, okay. We use temperature means X, relative humidity Y, wind speed Z. These are 3 inputs. Output F, FWI. We have 9 rules. If temperature is high and relative humidity is low and wind speed is low, then we can get F11. That's only is a linear combination. That's a traditional. Okay, P11X plus Q11Y plus R11Z plus C11. So in the paper, we have a detailed derivation process, how to develop those parameters. So here I show you guys 9 rules. As I mentioned, I want to indicate regularly we should have 4 inputs. Okay, but based on the most real active measurements, the rainfall has very small effect. So this can be confirmed from popular data set UCI, a forest fire data set. So everybody, if you go to website, you can find this website. If you go open that website, you can find the effect that rainfall have very small effect. So in this study, we only concentrate on the top 3 inputs. For that UCI forest data set, they miss 2 columns, FWI and BUI. So we added these 2 columns. We use the 3 inputs or 3 columns as a training data, temperature, relative humidity, wind, and FWI output. So we use those 3 inputs, 1 output to training this ANFI model. The tools we are using the MATLAB ANIF tool. This is a very useful software. Okay, I can show you guys structure this ANFS training result. Next slide. On the upper left, that is a structure. You see, we have 3 inputs: temperature, relative humidity, and wind. So we have so many layers inside. The output is FWI. On the lower right corner, that is a training result. Red color, that is star, is a training result. And the blue point data, that is a tracking result. So you see, it's very, it combined is very close for both training and testing or checking data. Very close. So I show you guys rule view generated ANFS. Left-hand side 3-column input. Right-hand side is output, FWI. By using this MATLAB tools, so you can move any input by vertical red color bar, and you can get output immediately in real time. Okay, that's very useful. You just moving, click your cursor, move your 3 vertical bar on 3 inputs. On right hand side, you can get output immediately. Okay, now let me continue. I think I finished ANF. Next one, we go to the artificial neural network. So for artificial neural network, everybody knows that. So this only give you quick. So we have inputs, we have a multiple hidden layer, we got output. Okay. For our study, output only single elements. A hidden layer, it depends on how many layers. If you only have a 3 to 5 layers, that belong to a shallow layer. If you have more than 5, we call the deep layer, the deep learning. Basically, neural work will build a neural work. You have to train it or adjust with the particular input and output together. Okay. As we did for the ANFS, we also use a modified data set. We added FWI and the BUI column. 3 inputs: temperature, relative humidity, wind, input, FWI, output. We totally use the 500 set to do this training. 70% as the training data, 15% as the checking, and 15% as the testing. Okay. Well, we use a Levenberg Marquardt training algorithm, MATLAB deep learning toolbox. We use these two tools. So we can show you some structure training result. Next slide. So say this is a structure. Okay, we have this input that's under input 1. That not means 1 input. That's only indicate a number of layer, 1 layer. Hidden, we have 8 hidden layer. Output 1 layer. Okay. The lower right hand side is training, testing, checking result. You can see we use a 10 approach, so the result is good enough. That is the comparison result. We try to compare by using 2 algorithms. One is ANFS, another is ANN, to do this estimation and prediction. So relatively speaking, for our study, the ANFS better, the method is better than the ANN method. This figure show you guys historical program. This only relatively error, this percentage, not exactly on the vertical 10.5, 1140. That's not is a real unit such as an inch, millimeter, and centimeter. No, this is a relatively error rate. Okay, if your error rate is 10%, your correct rate may be 90%. So from this figure, histogram diagram, we can see ANFIS is better than ANN. So exactly is I check our data result. It is 14% by using ANFIS better than ANN method. Okay. Based on the two approach, the comparison result I just showed you guys. This research is based on we have supported by the U.S. Department of Homeland Security (DHS). We have a grant award number. The viewer conclusion included in this presentation are not those of authored and should not be considered as necessarily representing the official policy, either expressed or implied, related to the U.S. Department of Homeland Security. Okay, this is clarification. Of course, this is a normal presentation. You should have a question, but right now you should not have a question. I appreciate everybody have this opportunity to hear our presentation, and you'll have a good day. Thank you. Bye-bye.